Okay, I want to show the difference between density and gravity. Density is the ratio of mass over volume of an object. Basically, it tells you how much stuff you have in a given space. Gravity is a force that acts between masses to attract them. For example, the mass of the Earth and the mass of this guy, which has 3 .44 caliber bullets in it, if you can't tell. Now, a clever guy, I'm going to weigh this also to show you. A clever guy by the name of Archimedes discovered, and this is, notice the Archimedes principle now, that if you have an object with a certain mass, and it says 56.63, I'm going to round that up to 57. So let's pretend this is 57 grams. That's approximately equal to 57 milliliters of water. So that's the part here. And I'm just going to demonstrate Archimedes' principle, because trying to describe it in words, I get all tongue-tied. This will displace 57, did I say? Yeah, just about 57 milliliters of water, because water has a density of about 1 gram per milliliter. So let's carefully put this in. Have to be careful because I don't want it to sink. There we go. And here we can see it's gone over 40. I'm going to mark it. All right. Hopefully that marking is nice and visible. So it's just raised the water by 57 milliliters. Let's take it out and shake off a few drops. I have a graduated cylinder here where I've measured out 57 milliliters of water. And let's add it to the beaker. And look at what we have. They add up. Now, Thrive and Survive was doing some weird thing about air pressure being responsible for rivers flowing downhill rather than uphill. And a convoluted explanation, and I was getting lost about it. And Globebusters on Sunday, they were talking about what would be an interesting experiment involving water leveling. Now, they were under the impression that because the Earth curves, if you filled a hose with water and simply had one end far away from the other end, that the one end would empty out when you opened up the hoses. But in reality, what's going to happen is their water will level to the same distance from the center of the Earth. That is what that's what they mean by water level or sea level. And water leveling has been used at least since the construction of the pyramids. Now, Mr. Thrive and Survive was going on about air pressure. He's saying the pressure of the air is pushing down on water. Well, that's true, but it doesn't mean it's going to make them flow uphill unless there's other higher pressure areas to push down and low pressure areas to allow the water to flow to. For example, during a hurricane or tropical depression, for example. Anyway, I'm going to show a new water level by putting my float back in, which takes it up another 52 milliliters. I'm going to mark it. Now, I didn't degas this water. Even though this vacuum pump I'm about to use, and it's going to make a lot of noise, is not powerful enough to make water boil, sad face, it can degas water. So there's going to be bubbles forming in there, but don't worry about it. That shouldn't affect the experiment in any way. Let's get a good seal. Water level is the same. I'm not worrying about the current barometric pressure, but I am worried about you being able to read the dial. And I've got bad contrast here, too much backlight. So how do I deal with that very quickly? Let's put something dark behind there. And don't worry, this is not a thread of any kind. I just want you to be able to see that the gauge moves down. Actually, I've got two of these, so let's block off even more light. I didn't anticipate this. It's not part of the experiment. I'm just trying to get the camera exposure right. Alright, now the gauge is visible. Good. So we've got the water level sitting with an object whose mass is displacing, well, it's displacing, what did I say, 52? 57, sorry, 57 milligrams of water. Actually, you know what I can do with this thing? I can do something else with this thing. Before I even run the, I just now thought of this. Before I even run I'm going to sink it. Now this will raise the water, will this raise the water some? I actually don't know. I mean, there's a bit of volume up here, right? And there's airspace in here. See, it's dry inside. So let's just deliberately sink this thing. Okay. It's actually gone down. So I've sunk it. And it's showing very close to its original displacement. That is from where I added the water. And if I pour the water out again, hopefully not, I spilled some, so it's not very precise. We're back to where we had added the 57 milliliters of water. I'm going to let it float this time, because really what I want to do is show that nothing should happen just because I pump out a bunch of air. The red scale is in kilopascals. The black scale is in inches of mercury. So let's get her going. Oh, oh, this vibrated out. Oh dear. No, don't tell me I'm broken. Murphy, how dare you create that law? Okay. It's only gotten to 88 kilopascals of vacuum. And it doesn't seem to want to go anymore, so I'm going to let it sit at that. It's not actually important. You'll notice bubbles have formed from outgassing. Watch them disappear. If you can see them, hopefully you can see them. I'm going to disconnect that. We get a bit of condensation. Anyway, the whole time, the water level has not been changing. Now, my normal method of getting this off has been to hook it up to the other hose. Will you go with no load? I think I burned, oh wait, I unplugged it. We run with no load. Okay. I'm going to just pop that guy off. I do it that way because it really gets wedged onto the gasket. So when I take it out, we go back to the original mass of the water. That is, the original approximately 350 milliliters plus the 72 that I added that matched the roughly 72 grams that this takes up. So I believe there, by using Archimedes' principle, showing the difference between density and gravity. I mean, see, this still wants to go down. Air didn't have anything to do with it. Water didn't have anything to do with it. It's nothing about cherries floating on top of stratified liquids of different densities that don't mix together. And really, the weight is just the acceleration of Earth's gravity, which is 9.81 meters per second, times the mass of this in kilograms, which would give you newtons. The scale just turned it back into grams because it knows the acceleration of gravity. It's built into how digital scales work. So hopefully I've made a reasonably clear experimental demonstration showing difference between density, gravity, and throwing into the mix Archimedes' principle. Any questions or comments? Be sure to just post them below. Signing out.